Yo, 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 let's continue this water adventure. And after having some problems with the normal calculations and the displacement approach, we finally committed to just trying to switch the quad edge on certain points on the water. So for instance, I think if we take a random quad, we take a random point, and the point itself and its diagonal neighbor if they don't have the same above ground state, then we flip the quad. And this actually gives pretty good results. I think the displacement approach resulted in some better results at certain points, but the displacement approach also made it extremely or way harder to calculate normals. So this one, we might just go with this one actually. Although not entirely sure I'm liking what I'm seeing here, but maybe. I think it's okay. But yeah, so I'm probably just gonna rely on this flip approach right now, because I think the overall it gives a better result and the normals are calculated in a much simpler way than the displacement approach. So we're gonna continue with this one. The implementation, so yesterday when we implemented this, we pretty much did it in a half-assed way. Just wanted to get it done, see what kind of result we get, see if it's better or not. So I'm gonna start today with cleaning that implementation up, and clean up water normal. This one we can probably skip. But yeah, we're gonna do all of these tasks, and when all of these tasks are done, that's when we're gonna start cleaning up or make the water look good. So we still have some boring tasks that needs to be done. Clean up quad flip approach. Okay, so we're gonna start with this one. Right now, I think we do it terrain fluid solver. Yeah, we have update fluid mesh, and before we do update mesh, we flip all quads here. Flip all quads basically goes through every triangle index and flips them. It's just because I couldn't get, let's see here. Yeah, I couldn't get this one to work because I think we're doing it the wrong way here. What we would like to do is we want to have an array like this and alter the array itself and then set it like this instead of altering this one directly like we do here. This one also led to a way worse performance. But luckily we have something called, what is it called? Terrain mesh. terrain patch mesh data. Okay, so this is the data we have, and terrain patch mesh. Primary data type, yeah. Explore solutions that does not include keeping the mesh data around. Not too sure. Maybe we can keep that one. But I also want to have a private because basically what I want to do is terrain patch. When we create, we create the triangles here. Actually, yeah, we can clean this up a bit. I want to split it, or I want to add UV position. I wonder if we, while we're doing some cleanup here, we might clean it up a bit more than I first anticipated. I think we can put most of this logic in terrain patch mesh. Mesh data length. What do we have? Resolution, terrain data. We create the mesh. We can do this in terrain patch mesh. Set vertex buffer parameters. Yeah, we can do this as well. We can do this as well. Then we create mesh data. What do we need here? We need resolution, IJ, dimension as well. Resolution, dimension. Yeah, that's all we need. Then we set the vertex buffer data. Then we create the triangles. Do I want to keep this as a native array as well? Maybe I do. Like, if we do this the correct way, we can actually do the triangle flips or the quad flips on the on a secondary thread. So that's nice. Fuck it. Terrain patch mesh. Create new. this one we might want to add triangles is equal to 6 times resolution minus 1, resolution minus 1. Mesh collider. Instantiate. Nah, fuck it, let's do public. Yo, what's up, Geralt? Good morning, good morning. Public void generate, I think. We're gonna do the generate in here. Terrain data type, primary data type. Do I? I'm not entirely sure we even use this. Primary data type. Nah. Source mesh, I don't care about this. We're doing a copy either way. Yeah, we might duplicate some calculations here, but I don't really care, honestly. Nah, in the future we're probably gonna read. Yeah, we're gonna read from data, so they're gonna be different either way. We only saved, I don't know, we didn't save that much time previously, so we might as well do it like this. So we don't need to send in this, nor this, nor this, because we're gonna create all of that in here. All we need here is int resolution and float dimension, I think. And we're pretty much gonna do if resolution mesh data length I think we can do generate mesh data length, resolution times resolution. We create a new mesh. I don't know, maybe I wanna mesh. Maybe we're gonna wait with this for a while, but do this one first. We do think we want to do something like this eventually. And finally, we also want to do mesh filter mesh. Something like that. I wonder if we want to save. Oops, sorry about that. I wonder if we want to save this one. We'll see. Okay, so what do we have here? We don't have a method for this, so we're just gonna do in fact, do I want to create something similar here? Maybe. Y times resolution plus X. Why? I think I like the idea of a method like this instead, but nah, maybe not. IJ and then we want to do, we want to use this one up here, and then I guess we want to use triangles here as well. So triangles is equal to can't we do to array? Or let's see. set. Okay, so we might as well go with a... I wonder what... Yeah, let's go with this. Just an array of ints. Triangles. And then we do this and just this. Okay, so now we create the mesh data in here. We create the triangles in here. Actually, mesh data. Allocate mesh data native array. Yeah, we might want to do this one. Create mesh data, create triangles, create the mesh, set the mesh, make hard copy. I don't care about this. So then in generate, we don't do this. Set vertex buffer data. Do we do this here? Yeah, we do. One sec. Yeah, we might index form. Never mind. This one we want here. Vertex buffer params index format. Vertex buffer data. Yeah. So recalculate bounds. Do we do that? Yes, we do. And then we instantiate here. Yeah, so we're just gonna take all of this and replace it with ground mesh dot generate resolution dimension. And I think we're gonna do the same with water mesh. Yes. And what do we have? Update all vertex data. Recalculate ground mesh at index. Update vertex data, we just update everything. Update mesh. Recalculate bounds. Is there anything else I want to do here? Update mesh. I'm thinking of adding mesh filter mesh dot triangles is equal to triangles. Recalculate mesh data. A little bit cleaner, this one at least. I hate these, I think. Update mesh, I don't even know. Let's see. Recalculate ground mesh at index. Recalculate water mesh at index, recalculate mesh data. Get water point. Yeah. Like the goal, I guess, would be to be able to use this or this method with the water. But I wonder, I'm a little bit afraid, like if we take a look at the water here, we're using two separate ones or separate method for calculating this right now, because when it comes to the water we need to check if one is above or below water, but actually it's all about, if we calculate the normal of this one using this one, these ones that are behind or underneath the ground, like they are 0 right now, how much would that actually affect? So it would affect this one pretty much, I think. But we're not doing any displacement anymore, so this one is pretty far from this and this point, so it might not affect it too much. I'm definitely gonna try it, but yeah, let's do it instead. So recalculate mesh at index. Here we do. Recalculate terrain patch mesh at index. I think it's this one we're calling. Terrain fluid solver. Recalculate fluid mesh data. Recalculate terrain patch mesh at index. Yes, and then we do recalculate water mesh at index. Recalculate ground mesh just does this. Yeah, let's do, comment this one out. Water mesh, height range, yeah. but we want to change. I think that's all we need to do. It looks a little bit weird because we're doing displacement right now, but we're not going to do it soon. Okay, we have something like this. It's rough, hopefully mostly because of the displacement. If we do this... Whoa. Do we not flip the quads? Yeah, let's take a look at that. Yeah, we want to flip the quads, see how it looks. Maybe we can get away with this. So I thought we called... The fuck? Flip quads. Oh. Yeah, this is just... Yeah, okay. Down here, I mean. Terrain patch, flip all quads. What do we do here? If P water is bigger than P height and... Oh, yeah. Okay, so why doesn't this work all of a sudden? Yeah. It doesn't work all of a sudden because at the end we do update mesh, and update mesh here does update vertex data, but it also does update mesh on the mesh itself, and this one set mesh filter mesh triangles is equal to triangles. So yeah. So what we want to do, just to make this, I just want to test this real quick. So instead of doing this, we're gonna do, fuck, is it private? I think it is. I guess we can do this. I guess what we want to do is something like this. Update mesh, update set. Where do I want to have it? Recalculate. That's what's here. Public flip quad. Actually, void flip quad. And we want to have an index here. And I guess we can do bool flip. If flip else. And we want to calculate index. Yeah, we want to calculate, we need this index and we need this index. How do we calculate? Triangle index x times resolution minus 1 plus y times 6. Yeah, and then we also want to do this. That's true. We probably want to make this into y times resolution minus 1 plus x, or yes or no? I think so. Or actually, no. Flip quad, we need to do int j bool flip so int triangle index, we need to calculate this one. I wonder 6 times, is this correct? 6 times resolution minus 1, resolution minus 1. Triangle index. So if x is 0 and y is 1, then we get 6. I think that's how we want to do it. I think. Yeah, let's do it like I j but then again okay. So if it's no flip, we just do this. If it is a flip, we do this. Or actually, we do this. Let me just copy from Okay, how do I want to test this now? So what we're gonna do is terrain, fluid solver, flip all quads. We definitely don't want to flip all quads. So we remove that one, and then we add this one back, flip quads. I think we call this one flip quads, flip quads, flip quads. And flip quads does P water, P height. We get patch, patch, patch. Get these. We can clean this up as well, I think. PG King, what's up? Good morning, good morning. I think we have to do it here, but what we want to do then is XY. So here we do water mesh dot flip quad XY true. Water mesh dot flip quad XY. Fuck, I think we want to do this. Bool flip quad is equal to so like if this is not true, then we want to flip them back, and we want to call so ground mesh and water mesh flip quad flip quad. Hopefully this will do. We're doing the displacement as well. That's why we're still seeing some issues here, but I think that's okay. So if we disable the displacement, what the fuck? Yeah, we have flips. We do have flips. But what the hell happened here? Yeah, are we flipping multiple times? Yeah, we can also see here that when we calculate the normals for these, we can absolutely not use other ones with that doesn't have any height, so we need to fix that. But what the hell happened here? I think the flips are okay, but for some reason... we don't flip it on the ground. That explains it. But why don't we? I thought I did flip quads, terrain patch, flip quad, ground mesh, flip quad, water mesh, flip quad. Ground mesh, water mesh. I think I know why. Because later on we do so terrain fluid solver, we later do recalculate fluid mesh data, flip quads, update fluid mesh. Here we do update mesh and we only do water. So so we flip the quads for both, but we don't update it for both. Update vertex data. I don't care about that. Update mesh. You wonder if when we do update mesh, might as well do we only call this one in terrain fluid solver? Okay. Update meshes, and then we just do okay, let's try this. And then I wonder if let's try it. But I also want to take this one and disable the displace multiplier. Definitely need to fix the normals, but other than that, it looks pretty pretty good, I suppose. PG King, that would look so freaking good. Yeah, and this is only the beginning. I'm pretty stoked about how it looks now and the potential we have. But yeah, okay, so we still need to figure out these normal calculations here. So it's not enough. Like, we have to... Fuck. So when we calculate the normal here, we just want to take this one and... we want to take this one, and this one into account. But actually, I think... yeah, we can simplify it. When we calculate this normal... or like when we calculate these normals, do I really care about... maybe I do. PG King, how long have you been working on that water mechanic? Quite a while, actually. I think we started in... was it July? Maybe. I think we began with it in July. Only worked about 2 hours every weekday in July. And then I also had some vacation. It's hard to put an exact hour on it, but I would guess... let's see here. Let me get back to you on that one. Quite a while, actually. I called the puddle of mercury in the wasteland of Lone Kid and his hat. Yup. But it's gonna look like water eventually, hopefully. Yeah. Eventually, hopefully. So yes, the only, like, we know how to calculate these. Do we? We know how to calculate these normals. It's just that it's not very pretty. But maybe, let's see here. Terrain patch. I wonder if we can clean this one up. Okay, for the water, I think we want to take all neighbors into account, not only the connected ones. But what we want to do then is we want to check for this shit. So if the water is visible or not. So recalculate mesh at index. Recalculate mesh data. Can we make this one prettier? It's a little bit frustrating. So basically we want to do this. We want to do this. We want to keep track of these. So goddamn ugly. And here we want this. It's currently such a mess, everything here. Okay, so for the ground, for instance, like it's always going to be like this. We're always going to have up, down, right, left, down, left, and current. And thanks to us knowing that it's always going to be these, we can simplify the calculations, which we have done in here. So this one and this one, I would say. The problem with water is that we only want the normals to depend on, we only want the normals of the water to depend on points that are actually above ground. If they are below ground, we don't want them to affect the normal, and that's why we have to do shit like this. Although we don't care about this anymore. Current water, current height. But. Terrain fluid point. Okay, we're gonna have to do it like this. But current water, we use it here. Current height. Point current. Get water point. I guess we can clean this up a bit. Let's see. Normal. Okay, so default is just normal up, normal instantiated false. I guess we can do point current position OSX. But one sec. One sec. It would be very cool if we could continuously calculate this normal, like when we're doing the fluid solver. But maybe. Because if we did it like that, we wouldn't need to worry about... maybe we... let's do it like this for now. Let's see what we can... After we've done these tasks, let's see if we can simplify it even more. Pack it... or reduce it even more. Like, I hate all of these calls. I hate having a outbool visible water here. One sec. Recalculating the normal for this one is so specific in this case, so I wonder if we want to do it in the fluid solver. Do we want to add, like, do we want to add a recalculate normal point here? Maybe. Yes, we would be calling this one current. Maybe. Or instead of doing offsets like this, we could do... Why is it so goddamn hard to make these or this pretty? Yeah, we need to check all neighbors. We need to do it in a certain order. We need to check multiple values per neighbor. Lots of ifs and else. I hate it. Remaps as well. What the hell? That is true, that is true. One sec though. Yeah, we need to get multiple values. Let's see here. Terrain, fluid point, get neighbors. We can order them by type, terrain data type. Wonder if you could do get neighbors. If we created a method like this that returns them in the order we want, but if we work with terrain fluid point, we probably want to do it in the solver, but it could, I think we can do it in a pretty nice way. Although I wonder about this one, we might as well. Yo, what's up, Hercules? We're gonna do this. Public list terrain fluid point get neighbors ordered by type. And here we just do so turn n. One sec. Get value type to list. That's how we should do it. How's the water coming along? It's coming along pretty good. I think we made a little bit of a breakthrough at the end of last stream, where we opted for a quad quad edge, like instead of displacing vertices to make the water look good on the edges, we flip quads instead. And yeah, it comes with some artifacts as well, but I think it's still way better than the first solution we had. And now I'm just in the process of cleaning everything up so we can make it be a little bit more streamlined, maybe even get some performance out of it. Terrain fluid solver. There we go. And then I wonder if we can do get neighbors ordered by type, get neighbors. I want to do why not? Terrain fluid point get neighbors ordered clockwise. Or just clockwise, get neighbors clockwise. But yeah, I think we're gonna do do we want, maybe we should just create one of these again. But I don't know. I don't know how I want to handle. Yeah, one of these can actually be null. So I think we're gonna do. Yeah, let's do this. Yes. For and then we do terrain patch neighbor get terrain patch on safe offset.x, y plus offset.y. And I want to do if it's not equal to null, otherwise. We want to do something for both of these, I'm pretty sure. And here we want to do if it's not... Oh, whoa, 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 1 sec. What the fuck? This one is supposed to be this one. Haven't we had any issues with that? That's a little bit weird. But never mind. We only have one patch, so of course. But yeah, this one should be this. So here we do this. Y. Otherwise, we do n.add new terrain fluid point. I wonder what happens if we do this. Should be okay. But if we later on do get value or set value, we're gonna have problems. But yes, we need to check this one. But 1 sec, maybe we should just skip adding these. Maybe. Let's see what kind of result we get if we skip it. Okay, so the idea then is that we calculate the normal here. Recalculate fluid mesh data, we do it here, I think. Update fluid mesh, calculates fluid spread, finish step. Pretty sure it's this one, but I want to see. Yeah, so we run this one as on a thread. So recalculate terrain patch mesh at index. Recalculate ground mesh at index. So we don't want to call recalculate terrain patch, we want to set recalculate mesh. Yeah, it's also a problem of which of these meshes we want to use. Recalculate ground mesh at index. Recalculate terrain patch mesh at index. Fuck, I want to clean this up. Yeah, because I guess I would like to have something like this. Let's see. Recalculate mesh data. Recalculate mesh data. Recalculate mesh data. I wonder if we can do... If we skip this one and do... Basically, I want something like public void set mesh data, int index, vector 3 position, vector 3 normal, and vector 3 tangent. And we just do something like this here. So mesh data at index is equal to new terrain patch mesh data position, normal, tangent, and then we pick the old UV. Set mesh data, and then we can skip this one. But then recalculate ground mesh at index. Recalculate ground mesh at index. Yeah, something I want to do here is recalculate mesh at index. Terrain patch mesh int I int j, and terrain data type. And just do this. this, and then we'll just do mesh here instead. So this one is way more general right now. So update all vertices. So update all vertex data. When do we call this one? Fluid solver. Nah. Do we really? Fluid solver, that's the old one. Okay, that's good. Yeah, we just do it from at the start, and yeah, so we might as well do recalculate mesh at index, and here we do ground mesh, and we want to base this one on terrain data type height, and then we do recalculate mesh at index and water mesh and terrain data type water by default. Then we do this and this. Update meshes. Okay, let's see what kind of errors we have. I'm gonna skip. I'm just gonna remove this one for now. Water normal, flip quad, flip all quads. Let's remove this one as well. So recalculate mesh at index. I want to do private. Yeah, we're gonna get to this one soon. Data index, Terraform data. Yeah, we want a brush here as well, I think. Set mesh data, recalculate mesh data. I don't think I care about this one too much. Terraform brush type, terrain data type. Why the fuck? Why don't we just go with type here? Or we could. Let's just send in the brush in question. Do I want to skip this here? Maybe. patch mesh is equal to, if type is equal to I don't know. So here we just do data index no, but we do terraform brush dot type, calculate we need the mesh here as well, that's true. Terrain patch mesh, update mesh. What the fuck? Not a big fan of this right now, but and then I want a this is how we did it previously, but this is not how we're gonna do it now. We calculate mesh at index, private void, set. Int I, oops. What more do we want here? We want terrain data type, vector 3 position. Fuck, do we want it like that? 3 normal. I'm not even sure anymore. Vector 3 tangent. Something like this. It was a playlist free life hack. Change your title to quickly developing a creature collecting game to boost your production speed. Yeah, I'm pretty sure people will just enter here and see that it's not very quick and then get disappointed. Okay, this fluid, terrain fluid point, what are we working with here? Int X and Y. Nah, it's not enough. Or is it? Yeah, one more thing. Terrain fluid point. Probably want to rename this one. Terrain point. Because it doesn't really have anything to do with fluid. It's general enough. So we could do set mesh at index. Fuck, how do I want to do this? Terrain patch. Recalculate mesh at terrain point. I have no idea what I'm doing anymore. Calculate mesh at terrain point. And then basically we want to do all of this in a nice way, so we can do it like we get normal here. Okay, so something like this. Let's see. Terrain fluid point. Get neighbors clockwise. That's about it. Or is it actually a list? Let's do it like this then. And then we do for int I is equal to 0. Yeah, I want to do it like this. I is less than neighbors dot count I plus plus. And then we can do it like this. PA is equal to, or P1. Terrain fluid point P1 is equal to neighbors I, and terrain fluid point P2 is equal to neighbors I modulus neighbors dot count. But do we want to do it -1 or I plus 1? I mean, like that. So then we have 2 points. So we have already skipped all of this right now. I think we still want to do this normal instantiated. So let's put it here, and then we just return normal at the end here. Oh, actually not return, but yeah, we want to calculate some stuff here. But I wonder, let's see. Okay, so what do? We need to figure out if we have visible water or not, and we need it to be true for both. If so, we do if p1 dot get value water is bigger than p1 dot get value feels a little bit weird that we don't already have terrain fluid point, that we don't have a comparison here already, like this one. But yeah. So get value, water is bigger than height, and I want to do the same, but we want to do it with P2. And if this is true, then we want to do these things. What do we have? Normal, and we want to calculate a normal, and then we want to double check these things. And here we do P, P1. Yeah, we need to recreate these points as well. That's true. And this is where we're gonna have to work with, do some remapping and stuff here. That's true. So yeah, we're gonna get to that, but I just need to run AFK real quick first, so be right back. Okay, back. Sorry about that. So yeah, we need to create these points, and we need them to be in world space, I guess it is. Did we do that here? Yeah, we did a remap. Visible water. And then we did a remap, okay. So I guess we can just do p vector is equal to p vector is equal to fuck me. It just feels like it's becoming uglier and uglier, honestly. Yeah, not a big fan. New vector 3. Terrain patch dot position OS. Do we want it in? Yeah, we probably do. P.x, P.y, and then dot x, and then we do height range dot remap. Height range dot remap 0 to 55. P dot get value terrain data type water. Okay, something like this, just to be recreating this point, and we want to do something similar here. Fuck, terrain fluid point. Couldn't we just like get value in object space or get value in world space, but then transform value gonna have to think on that one, because then we also want to do the same thing here twice. P1, P2. Something like this, and then we do P vector here and here, P1 vector and P2 vector. I don't know, but after all of this we should have a normal at least. That's something. We have a point, we have a normal. Not overfilled with joy about this implementation yet. Maybe we can clean it up a little bit later on, but yeah. P vector, and we have the normal as well. I don't normalize, so I guess we want to do this one is extremely specific as well. Let's just keep it like this for now, and we're just gonna do water mesh dot set something. Set mesh data. Is that true? Set mesh data at index. P.x, P.y. Position then is P vector. Normal is normalized. Tangent. I'm just gonna put this one as this for now, I think. Although let's just see what we have right now. I wouldn't be too surprised if a lot of things doesn't work anymore. Yeah, we need to fix this one first. But so we don't do this anymore. We do so recalculate fluid mesh data. Dot recalculate mesh at terrain point P. Hmm. Fuck, did it actually work on first try? Okay. Yeah, I think the normals are way better now. We still have this, but I'm starting to think that that's how it should be, because we have it's plain here, pouring down here. A pretty damn good result. Okay. It's still not super pretty, but I'm starting to understand like the strength of these temporary structs. And maybe we should just have a method within one of these that calculates the normal instead of having it here in the terrain patch. Do I want to do that today? Really? It would clean up. This one would be cleaned up as well. Flip quad. We might as well go with terrain point here. Yeah, it's gonna be hard. We need to get the tangent in place as well later on. But for now, yeah, this will work. That's rough. What's happening here? Maybe not. Yeah, I have to remember as well that water... Yeah, let's take a look at this shader. We're pretty much terrain, terrain water, procedural water shader. Let's do... Instead of outputting the dot product between world up and normal in world space and then inverse lerping it, so we have it between 0 and 95 and 1, let's just do return float 4 normal world space 1. One more thing though. Normal world space. So it's -1 and 1. We want to get it so times 0.5 plus 1. So -1 and 1. So minus 0.5, 0.5. Then no. Plus 0.5, is that it? Yes. Do we get a little bit of a better result then? Yeah, it's not that much of a difference, but I think think it's good. Hmm. This one. Why? Yes. Yeah, we might need to... So this one was originally like this, but when we flipped it, so we flipped it because this one had water, this one did not. So we flipped it like this, but the problem is that this one has water, this one does not. So like we want to be more careful when we flip and when we don't. Like for this one we probably don't want to flip. Neither for this one, I don't think. Yeah. But still, it's not too bad. In this case, we actually changed the terrain quite a lot, so it's actually visible. That's one problem with changing the... I don't care about that. I don't care too much about that right now because I think there's an easy way around it, and or multiple actually, and I'm not sure how visible it will be. Like this is the the angle we have here on these walls are like worst case scenario. We probably won't even support that type of edges in the final game. But if we decide to do it, I think there's a few easy ways around it. But yeah, okay, normal's okay. We have it a little bit cleaned up, not too much. I'm still not entirely sure of how I want to handle this. Like the more the more we start using terrain fluid points at other places than terrain fluid solver, the more I'm trying to think if this should just be something we always keep around. But I don't know. Clean this one up a bit. We're gonna do it by terrain fluid point, get neighbors clockwise, get neighbors ordered by type, public wonder how return like we could make this one utilize this one, but else return new terrain fluid point. Okay, because I'm thinking of doing flip quad, let's just do terrain, fluid, point, P. Then we don't need to do P water, P height, and we can just do we just do N or fuck, do I want to do it like this? And then we just do P, because I think we can simplify this one and this one, or we can get some performance boost here. Let's see, recalculate mesh data. We use it here. Yeah, let's jump to it. Flip quads. I think we can actually do this one. I think we can do this on a secondary thread, so we can do both this one and this one. Recalculate fluid mesh data. Calculate normals. In fact, do I want to flip it first? Nah, doesn't matter. But what I'm saying here is we can do P flip quad. So update fluid mesh data, update fluid mesh. That's nice. So, do we want to do flip quads first? No, we remove this one, update fluid mesh data, update fluid mesh. This one we can't do on a thread, so that's why we have to do it like this. Yes, and we just skip this one, and then we skip this one. I still think it looks this? Oh, are we not doing it correctly? Yeah, something's wrong here. Yeah, we're not flipping any quads anymore. Okay, so is it because of update fluid mesh data? Here we do P terrain patch flip quad P. Flip quad does this, and what we do, terrain fluid point N P get neighbor 1 get neighbor X offset Y offset. So, okay, what do we have here? P get value, water, P get value. Okay, why doesn't this one work anymore? If it's equal to null, there we go. Yeah, okay, this looks good. I'm still not extremely happy about how it's implemented. But I mean, it's better than it was. Yo, what's up, E-Dragon? It's definitely better than it was. And yo, Wormius. Cute character. Yeah, I think so. I think so. And thank you. Terrain fluid point. Yeah, I'm gonna have to think about those. But let's see here. We have clean up quad flip approach. Yes. Clean up water normal calculations ish. Research if normal of fluid can be set during fluid solver. The problem with this being that we need to rely. Oh, maybe actually. One sec. What the fuck? Okay, so research if normal of fluid can be set during fluid solver. When we calculate the normal, it relies on its neighbors, but we could probably so let's say find reachable minima, for instance. We take a point, we get all of its neighbors, and here we spread the fluid, right? We always, when we do the spreading, we always do it in the, like we order it by height. Yeah, whatever. I think we're always moving. This makes me worried. It should be okay. But like when we have spread it to all of its neighbors, then we know what the status is of the neighbors, so we should be able to calculate a normal here pretty much. What sucks, however, is here we do get neighbors. If we want to calculate the normal here, we want them in a counter or a clockwise fashion, and that it would be okay here, but get neighbors ordered by type. Here we ordered them by height. Do we need to do this anymore? Height difference? I don't think we do. No, we don't. We don't need to order them here anymore, because we're gonna do all of these either way. So n, what do we have to gain by ordering them by height? If we could do this, if we can do this, and then we do get neighbors clockwise, and then after we have spread it to all the neighbors, here we calculate the normal for the point in question, and which means that we can actually do I think we can clean this up quite a bit. Update fluid mesh. Because that would basically mean that we do this inside of the, so we don't need to have, oh man, this might be, yeah, we might be able to do this. Update fluid mesh data. So what if we just put all of this logic within here? But one thing. In check for fluid overflow, or we can do update stable fluid state. Yeah, let's clean this up as well. here we actually want to do it for end nodes as well. Can we have a problem here? Maybe we... yeah, maybe. Yeah, I think we could fix it, because the biggest problem is here. We can't really... I guess we have the same problem on... I guess we have the same problem on this one as well. Like, we want to calculate normals for neighbors that don't... So in the else here, we want to calculate the normal for this one. The problem being that... we can only do it when all of its neighbors has been set, yes. So we're gonna have to add it to unvisited points, and then we're basically gonna have to check here if water is bigger than... yeah. So maybe fluid spread is bigger than water temporary. If so, we're gonna have to do some changes here if we want to be able to calculate the normals during the run, but it would be amazing. It really would. It would be very cool. So so this can definitely be done, and while we do this, or while we alter this one to better work with, so while we try to bake in the fluid calculations within the different iterations, we might think about these ones as well. So make moving diagonally more costly, keep finding minima visuals when moving on to next step, make it possible to exit check for fluid overflow early. Yeah, make terrain fluid solver work with previous water data. This one is very interesting. But it would be very nice if we could get rid of this one, for instance. Update fluid mesh. Yeah, so, I just want to. I want to get rid of some clutter here, but Wormius, what's up? Are you not sure you have a cleaner way? What do you mean? Oh, stopwatch restart. Yeah, there's a lot of clutter here, which I want to get rid of. And, I mean, I sure not have a cleaner way. Now, like, this is pretty much set in stone right now. What we can do is we can move this, this, and this into their separate methods like this. I think that would be amazing. I do see some repetition. I don't know. What repetition are you referring to in this case? Yeah, we have these. The apply this one. And we do apply. Yeah, that's true. Yeah, we can still remove a lot of clutter here. Update fluid mesh. I think we're probably going to we have this one. I think we have this one as well. But this one I want to bake in. So we want to bake this one into this one and this one into this one. Ish. Update fluid mesh. I think we can do it like this instead of all of this. I wonder if... Yeah, I think we can update this. We can update this one. Or we can add it in a method in fluid or terrain fluid point, I think. Okay, I'm a little bit nervous about changing stuff within this class. We're gonna try it for every little change. Okay. So everything works up to the last point. Back a step, but that's okay. Okay. This one doesn't even fail anymore. That's an old. Keep it like this. I wonder if I want to put this in. So this one is the same as this one. We spread the same But here we do water temporary, water temporary, water temporary. Water temporary. We can probably put this in one method actually. Same here. Do we really only care about, let's see here, if wonder if we want to do what's temporary. I wonder if I just want to bake all of this into one method. Honestly. I guess we could just do private bool spread fluid. The only problem being that we dry constant. So dry constant and diagonal cost. And in here we do, I wonder, let's take this one, put it here. So spread fluid, we do fluid spread is equal to calculate fluid spread amount, Pn, dry constant, diagonal cost, and type. If fluid spread is bigger than n, get value. Here we want to do type. Actually, we want to do it here, here, and here. We do this. This one we always want to compare with height, and then we have this one left. So we're gonna do it like this. We take this one, and here we just do return true. But if we get down to here, we return false. So spread fluid, we calculate a fluid spread or a new fluid height. If it's bigger, if it's not bigger than what we currently have, then we return false. If it is, we set the value to be that one, and then we check if it's bigger than height. If it is, we return true, otherwise we return false. So spread fluid, we should be able to simplify quite a lot here by just doing spread fluid from P to N 0 0 terrain data type water. And then we do the same thing here. So we replace it with height difference. Do we really need that one here? So spread fluid P to N, and we're gonna keep it short, so dry constant, and then diagonal we're gonna go with 0, and terrain data type, is it water temporary? Yes it is. So we replace all of this. One more thing, we need this one still. So if spread fluid succeeds, we want to do unvisited points at n. I really want to get rid of these as well. Should be able to. Should be able to. But let's see, Pn dry constant, but here we want diagonal cost as well. And we're gonna work with water temporary. Okay, something like that. Dry constant diagonal cost. We don't even use these anymore, right? Okay, it's taking shape. It's shaping up. Terrain fluid solver instance. What the fuck is this? And this one is old. I think we can remove this one. Oof, that one is rough right there. The fuck? Should be okay. We probably want to keep this one like this. Yeah, we need to... We just want to flip it. Fuck. We want to flip it if... if the other two are the same. I think. Or... I don't know. Yeah, we do. We just want to flip it if the other two are the same in the end. So, for instance, this one is a bad flip. So is this one, because we're flipping from one point that is in water, one that is not, to one that is in that is in water and one that is not. So we don't really need to flip the quads at those points, but we're gonna get to that. We're gonna get to it. Okay. We're just gonna scale off more and more and more and more and more. So yeah, these affected points. So it's, we use it here. We use it when we call update fluid mesh data. And update fluid mesh data, what it does is we update position and normal for the water points. And then we send it into update fluid mesh, but this one, it pretty much only uses affected points to get the unique terrain patches, the ones that actually needs to update the mesh. So if we could get this another way, that would be nice. And then if we could bake this one into the different stages. So would probably be when we're done with this one. So down here, we're gonna call a method for updating the height and stuff. But that would clean up the code. We don't have to do an additional for loop and stuff like that. But if we want to do this optimization, we might need to keep the affected points, I think. Because basically what we're doing is we are running multiple iterations after one another. So we do the first iteration with water value 0.1. If we don't find what we're looking for, we increase to a water value of 0.2, and then we run the same iteration again. Currently, we start from the same point every iteration, and we do like spread outwards. But that means like we spread outwards from that point with 0.1 value. If that fails, we spread outwards from that point with the 0.2 value. And we're doing a lot of unnecessary duplicated spreading, basically. If we already have the affected points, we can just, so when we increment the water amount we're spreading outwards with, then we just loop through all the affected points first and set their value to the previous value plus whatever we increment the water amount with. So I think we need, like, if we want to do that performance improvement, we need to keep this one around. But we can actually do this here as well. So if this one fails, that means that never mind, one sec. It can fail if we're trying to spread less fluid than we have. That's true. But then again, now that sounds really true. Yeah, if we want to do this one as well, we're gonna have to save edge points. Like, we want to save every point where the spreading of fluid does not succeed. But yeah, we can definitely do this. We can bake this one into whatever we're doing. It should be as easy as... do we want to do the flip quad as well? Maybe we do. Maybe. So we want to do it here. And we want to do it here. And here. Unvisited points, do we need to... In fact, do we really need to sort them here? I wonder. I don't think so. Check for fluid overflow. Nah, I don't think we need to. Don't think so. Do we need to... Here, on the other hand, I think we need to sort them, yes. This point, it would be very nice if we could skip sorting it. I want to try that first. Yeah, previously we needed to sort them because we were doing the overflow calculations in a different way. Now we do it in a iterative way, which is much easier. But I'm pretty sure we don't need to sort them. I sure hope so. Okay, nice. Indeed, Kulorski. I got tired of the mercury, so we switched it out. Yeah, what's up, PG King again? Yeah, I think so as well. Thank you. Slowly but surely, we're gonna make it more and more and more awesome. I hope. Okay, let's try it. Let's try it with check for fluid overflow. So when we check for fluid overflow, we do it here. Check for fluid overflow is stable, so it's stable fluid amount. And then after we do update fluid mesh data, so let's just do this with this one. Update fluid mesh data. Let's jump to it. And we take these. So we did this in check for fluid overflow. Check for fluid overflow. So when we're done with the P, when we have spread to all the neighbors, what I'm wondering is, can we do this here? So we recalculate mesh at terrain point and flip quad. I wonder. Yo, what's up, Fabic? It's going pretty good. Pretty good. Just doing some cleanup right now. How about you? How's your day going? Yeah, okay, this is not good. Oh yeah, I know why. Fabic just woke up. Damn. Yes, because if we do this here, we also want to do it for these points. Yeah, that was the big problem. Fuck me. Yeah, the big problem is that we want to do this for some... Like, we want to do it for... okay, so let's say n here that doesn't get added. We want to calculate this for n as well, but we have to make sure that all of its neighbors that should get water have already gotten water. Otherwise we will get the wrong calculations here. And how could we do that? Hmm. We do want to save edge points, that's true. But do I want to do it now? I don't know. Hmm. We're gonna move. We're gonna move that one back for now. Just keep it like this. Maybe we could possibly find some other way that we could cut or clean up. But those parts, I'm gonna wait a little bit with those until we have all of this in place. Because if we stop pouring here, I want to be able to pour here again and just increase what we already have instead of starting from the beginning. And then we would like to be able to stop here, and maybe we could do run to here, and maybe, I don't know, start pouring here. Yeah, so we want to fix those things first. And we're talking about yeah, this one definitely. This one, okay. Make terrain fluid solver work with previous water data. I don't. I think first of all, I think we're doing a. During the experimental phase, we did. Let's see here. If it's running return. The first thing we do is we move data water to water previous, and can we skip doing this one actually? Because no, we can't. Yeah, and then we do this. We want to do it here because if we exit here, we don't want to do it. And let's see. Find reachable minima. Here we clear data water temporary, but that should be okay. Yes. Fuck, I want to spawn. We're gonna do it like this. Okay. Find reachable minima. If minima is found, we do this. I don't want to do this anymore, so we're just gonna skip this one. Instead, we're gonna add a sphere or something at that point. So it's gonna be okay. Finished step 1. We have found a minima here. So actually, do we have? Maybe we can just do. I would like to hide it in finish step. Apply and move data. Yes, of course. Okay, but the only thing I want to do is like after find minima step, I just want to highlight the point in question, so the minima. And let's see, private void finish step description, and gonna add a p like this, and let's do create primitive type sphere. And then we do finish step. Because the thing is, like, currently we have altered the water mesh to visually show where the minima is. So that's the spike we get in minima. I want to remove that now. I want to do first of all, I want to keep finding minima visuals when moving on to the next step. So the flow of water from wherever we start adding water down to the minima, we want to keep that one. But then also, if there already is water at the minima, we want that to override the minima visuals, or the minima finding visuals. Pretty much I want to make it look more like water. But let's try this one. We're gonna do finish step 1, find minimas, and we're gonna send in m.p because we have a minima at this point. And what do we do here? Environment control apply data water. Yeah, because in the end of find reachable minima, we set if height, okay, if height is bigger than water, then we set it to height plus fluid unit, otherwise we set it to water plus fluid unit, and then we set this one. Okay, so it's the water. Okay, it's water we're working with, and that's good, I think. Yeah, it is. But I wonder, where do we have the reset? Somewhere here we're having a reset. Move data, reset source false. Maybe. We fucked it up with this one. Let's just take a look at what we have so far. I'm just wondering why we're getting a reset. Let me show you what I mean. Okay, there we have the minima now. It's visualized by this sphere instead. I think that's good. Guess we're gonna have to remove it eventually. But okay, if we stop here now, and if I add a new, and then we start from the beginning, and I don't really know why, because, okay, I know why, I think. Check for fluid overflow. We're working with water temporary. We clear data water temporary here. I'm not that sure we want to do that. Okay, this is where we want to fix it. So we're pretty much clearing water temporary, adding a start fluid to it and start spreading. What we want to do is we want to move water or water previous into water temporary and not clear. Water temporary, I guess. So when we're done here, we have in water, we have the finding minima stuff. In fact, do we just want to jump to water, maybe? Like, do we want to work with water here from the get-go? Maybe we do. What would happen if we worked with water here instead? So we don't clear water, and we set the value of M to be water temporary, but we want to do it we set it to be m.getValue.water plus fluid amount. Hell yeah. Or maybe if we want to keep water temporary here, yeah, maybe we do. But then we move data from water temporary to water. Why do I want to work with water temporary here? What makes it easier to work with? Is it this one? No, I don't think. I think we can work with water here. The only thing we need to worry about is the initial value we set. We could either go with fluid amount. So here we start with 0, then fluid unit, and every time we add fluid unit. Or we could read whatever water amount we... yes. Okay. I want to do a few changes here. Or I don't really know if I want to do them now, but I think... because I really have to run soon, and I don't want to change this one too much just at the end. But what I think we're going to do is... So when we find the minima here, we set the water value to be equal to if we're at a point that doesn't have water, we set it to be equal to 1 fluid unit. If we're at a point that has water, we set it to be equal to water plus fluid unit. I think we're going to skip this one and just don't do anything. So we're going to check this. If it's true, we're going to set this. Here. So that's what we're going to do here. And then before we jump into this one, fluid amount here is not going to start with 0. The initial value here is actually going to be whatever water value we have at the minima. Yo, what's up, Robert Pattinson? I think that's what we want to do. Because that means that we will render the water here. Yes. And if this works, we're gonna speed things up a bit as well, because we're not gonna do... I guess we need to do... Ooh, I might be a little bit worried about this one. Maybe not. Maybe it's okay. A little bit worried about this. But yeah, if we can make it work tomorrow, then we don't need to do... we don't need to do... We don't need to clear this data. We don't need to... We don't need to clear this data, and we don't need to move this data. So it's gonna be wonderful, I think. Yeah, but that's what we're gonna do first thing tomorrow, because I have to run now. Work with water instead of water temporary in check for fluid overflow. Great. So that's what we're gonna do tomorrow. Yeah, I know, Fabic, I know. But okay, so I think still great progress today. Very nice, cleaned up a lot of things. Gonna make it easier tomorrow. Thank you so much for watching, everybody, and have a great rest of the day. Thank you, Fabic. Appreciate it. Appreciate it.